grade 10, so we're going to start with linear inequalities, and I don't want you to treat inequalities any different to equations. Treat them like a normal equation and you'll get most of your marks just by doing that. The only thing that you need to be aware of is that if you multiply or divide by a negative, the inequality symbol must change direction. Why? Because we can say 6 is smaller than 10 in value, but if we were to pop a negative in front of each of those numbers, negative 6 is no longer smaller in value than negative 10. Negative 6 is closer to the positive side of the number line than what negative 10 is. So that's why we have to flip over the inequality symbol when you multiply or divide by a negative. So also note that your answer is never one value for an inequality. It's actually a set of values, and there's different ways to represent these sets. You can do it on a number line, or you could even use interval notation, and when there are those inequality symbols, that's what we call set builder notation. So these symbols, I like to call them crocodiles, and we know that a crocodile always swims towards the bigger meal. If you have a crocodile with a double stroke at the bottom, I like to also call it a double chin, then that means that the maximum or minimum value of the set is included in the set, and if you write that in interval notation, you use square brackets. If the inequality symbol does not have a double stroke, then the maximum or minimum value of the set is not included, it's excluded. And if you write it in interval notation, you use round brackets. I'll demonstrate all of this by means of an example. Here we are asked to solve for x and illustrate your answer on a number line. Now let's have a look. 1 minus 2x is greater than x minus 2. So for which values of x will that expression be true? Just treat it like an equation. And what do we do with an equation? We always get our variables to one side and a constant to the other side. So I've left my negative 2x and I've brought over the x to make it negative 2x minus x is greater than, I've left the negative 2 in place, but I've brought over the 1. So to simplify, we have negative 3x is greater than negative 3. Now remember what I said, to get x all by itself, we're going to have to divide by negative 3. But the minute you divide by a negative, flip over the inequality sign, and there you'll get x is smaller than 1. Now what does that mean? Let's just see for interest's sake. You don't necessarily need to know this, but it will definitely enrich your knowledge of linear inequalities. If we called this equation on the left 1 minus 2x f and sketched it, it would be a negative gradient straight line cutting through the y-axis at 1, right? So it would be that blue line there, something like that. Then gx would be y equals mx plus c, x minus 2. So it would be a green line with an equation of 1, but it's been dropped down by 2. So its y-intercept would be negative 2. Now that point of intersection right over there is 1 because we have solved for the point of intersection by treating this inequality like an equation. So we know that 1 is where they cross over each other. And before 1 minus 2x, the blue graph, f of x, is greater than. It lies above the green graph. So that is what we are actually showing as an answer. We're saying every single x value smaller than 1 will have f lie above g. If we were to represent this on the number line, we would have to take that segment of the x-axis all before the number 1. So I'm just repeating the x-axis in that yellow sketch, and I'm jotting down where number 1 would lie. It could honestly be anywhere on that line. But then I'm showing you that the segment of the x-axis starts at 1, and it includes every single value that was before 1, hence the arrow to the left. Also note that if you were to write this as a set, and I know you've done this in interval notation, you would say, what is the very smallest value in this set? Well, it would be here, negative infinity. Let me show with a laser. This over here, this segment of the x-axis is our answer. What is the smallest value? Well, the arrow is pointing left to negative infinity, and that's why we have negative infinity in the interval notation. And what is the biggest value in the set? It's a 1. Can we include that value? No, we can't, because the crocodile, the inequality symbol, does not have a double stroke. It's saying x is smaller than 1. It is not smaller than or equal to 1. And that's why the circle in the number line sketch is also open. It is not colored in. It's not a solid circle. It's an open ring of a circle to show that it's every single number to the left of 1, not including 1. Now, let's look at this next graph. 2x minus 5 is sandwiched in between minus 1 and 5. Basically, they're saying if 2x minus 5 is a straight line graph, it would probably look something like this blue F over here, steep gradient of 2, y-intercept of negative 5. They're saying for which x values will the y values fluctuate between minus 1 and 5. So I've given an estimate of where 5 and where 1 could be on the y-axis, and the corresponding segment of the x-axis is our answer. So that little yellow rectangle right there represents the set of x values that correspond to the y values between negative 1 and positive 5. Now, you don't actually need to know that to solve this inequality. You just treat this inequality like an equation. However, what you do to the left, you do to the right, and you do to the middle. So let's get x all by itself. First things first, we want to get rid of that negative 5. So how do we undo subtraction? We add. But what you do to the left, you do to the right, and you do to the middle. So I added 5 to my middle to get rid of the negative 5, and then I simplify what's on my left and my right, ending up with minus 1 plus 5 gives you 4, and 5 plus 5 gives you 10. Now we know that 2x is sandwiched between a 4 and a 10. Look at how I haven't even worried about the inequality symbols just yet. We're treating it like an equation thus far. So now to get rid of the 2, I go and divide every single term by 2, and I end up with x is sandwiched between 2 and 5. Now listen to my wording. X is greater than 2 or smaller than or equal to 5. So let's figure out that on a number line. Basically, that is the segment of the x-axis, that yellow little strip of the x-axis over here. Starts at 2, ends at 5, because that's what we've calculated using our inequality. Now, we jot down those two numbers on the x-axis, 2 and 5. We know that x is between these two, but because x is greater than 2, we draw an open ring of a circle. And because x is smaller than or equal to 5, we draw a solid circle on the right-hand side, and we connect the dots. So this picture means x can be any value between 2 and 5, not including 2, but including 5. Now, for interest's sake, how would we write that as interval notation? Once again, smallest number in the set on the left, biggest number in the set on the right. We included the 2, and so, we did not include the 2, so we used a round bracket, and we did include the 5, so we used a square bracket. A summary of all of the notations is on the next slide, and then you are ready to do your homework activity, which is listed as well. You can do it today, the 18th of June, or you can do it in class tomorrow. Do me a favor though, jot down some notes today, and so that you can come into class tomorrow and get straight on with your work. Enjoy.